Okay, now so today I'm going to be showing you how the combined gas law is placed into an effect. So my materials for today, I need my plate, 32 count of waterproof matches, a tall glass, has to be tall,
That's tall,
with water, no specified amount, just water, and so that you guys can differentiate it. I have red food coloring here. And my favorite part of this whole experiment is I got to use my Hello Kitty eraser. Alright, anyways. So what I did was I went ahead and cut a hole in it, in my Hello Kitty eraser right there in between the eyes. I'm going to go ahead and place that on the plate. Next I'm going to go ahead and take, I'm going to go ahead and take one of these waterproof matches and I'm going to stick that right in that hole right in between Hello Kitty's eyes right there. Okay. Next what I'm going to do, I should probably put my matches back in the box that fell out. Anyways, so now what I'm going to do is I am going to get this red food coloring and I'm going to place it into the tall glass, specified tall glass of water, like so. Not too much, not too little, just the right amount. Okay, that's a little, that's perfect anyways, because I always get the right amount. Mix it up a little bit.
Not Kool-Aid.
If you would like Kool-Aid, you could drink some, but this is an experiment. Anyway, so now what I'm going to do, let me fix my box of matches still. Okay, so now I'm going to go ahead and take my red liquid, or Kool-Aid if you must want to call it that, and just pour it in on top of the plate.
I like Kool-Aid.
Like such. And then I go ahead and I take my other match. Dun dun dun. Alright, so now I'm going to just light this match up that I have on top of Hello Kitty. And it blew out. Alright, so we're going to go ahead and try this again. And this is a cool thing because since these are waterproof, you know, I can mix it up in the water.
There you go.
Hey, maybe if I light up, alright, maybe they're not waterproof, but let's just try this for a third time.
Are they actually waterproof?
That's what it says on the box. They lied to me, but whatever. We'll try this again. Alright, here we go. And it blew out. So, let me go. Wait. Let me go ahead and turn this fan off real quick. Maybe that's the problem. Alright, now that the fan is off, this is what, try 4. And this is a deformed match. I don't even know if this one's going to work. And it broke. Alright. So, here's try number 5. Alright. It is time. And we have flame.
Finally.
So now, as you can see how the candle is burning, now what I'm going to do is put the combined gas law into effect by placing the tall glass over the match. And as you can see, as the temperature had increased and then decreased in there, the gas inside created an amount of pressure that basically created a vacuum, which is why liquid is now in the cup, which wasn't there before. And just to prove it, go ahead and zoom in a little bit on that. When I lift up the cup, it's probably going to make a mess. So,
is it going to suck in more?
No, it's not going to suck in more. It's going to release what's in the cup out.
Alright.
And it's going to make maybe a mess. I don't know. Let's try it. Uno, dos, tres. And that is a combined gas law in effect. Welcome to the University of Harvard. Wow. I never thought I would see this day. Let's see what I can learn today. You like the guard dog or something? What's up? Try and ruin my education. Excuse me, ma'am. Do you know where Chemistry 101 is?
Through there.
Through there? Alright, thank you. Is that Professor Ogunfoken's room?
Yes.
Alright, thank you. Excuse me, sir, are you Professor Ogunfoken?
Well, it's Ogunfoken. And yes, it is.
Well, it's nice to meet you, sir.
Nice to meet you too.
So, sir, what are we covering today?
Today we're going to be covering Charles' Law. And the equation that deals with that is V1 over T1 equals V2 over T2. So,
with this experiment I'm about to do, I should be able to demonstrate how those vary directly. So we have here a bar of soap and a paper towel. And we're going to put this on here, and then I'm going to put the bar of soap in the microwave for a minute. And as the temperature increases, we should see how the volume increases as well. About to put it in there for a minute, about a minute. Alrighty then. Let's see what happens. So as we are about to open it, you should be able to see how the volume increases. And there we go. Big, ew, this smells like crap. But big marshmallow looking thing. Well, there is our original bar of soap. And that, my friends, is Chemistry 101 at its finest. If Oscar was here, he'd probably think it was a marshmallow. But it's just soap. Okay. That's crazy. Yo. With solution.
What's up, Robert? Hey, Kevin. Hey, can you help me out with solution, especially with the ideal gas law?
Alright, sure. Do you understand what the formula is for it?
No.
Well, like the most common formula would be PV equals nRT. Do you understand what each one represents?
P represents pressure, V volume, N is the mole, and R is the rate of the pressure, and T is the temperature.
Alright, so do you understand like how you would apply it to a real world scenario?
Can you help?
Sure. So like let's say you're using a tire, alright?
Okay.
So if you increase the pressure of the tire, do you know what would happen? Either the volume or the temperature would decrease, alright?
Okay.
Do you understand why?
Why?
Because like you have to manipulate the formula to where you have to find like the volume of the pressure, and when to find the volume of the pressure, like after it increases, you would have to decrease it. Either the volume or the temperature would have to either increase or decrease. Alright, come with me and then I'll show you an example.
Okay.
Alright, so do you see this part? Yeah. Alright, so do you see how strong this tire is? Well,
Yeah.
one of the main reasons why the tire is so strong is because they added pressure to the tire. Now when you add pressure to the tire, it's going to cause to a change in the temperature or the volume based on the ideal gas law.
Okay.
Alright, so are you good with the ideal gas law?
Yeah.
Alright, let's go.
Lanjut di Apes.